Hi, everyone. I hope you're all safe out there. Thank you for sharing in the chat. Where are you from? I see your people have joined us from all across the globe, so that's very exciting. Thank you for joining us today for this great webinar we have planned for you. We'll see how we can make the most out of TestProject's Python OpenSDK, which is 100% open source. And we'll see what's new in the Python OpenSDK, and we'll learn how to orchestrate an entire CI/CD pipeline from scratch. So just to take over of some housekeeping issues. So by the end of the event, you will all receive directly to your email a full recording of the webinar, so don't worry about that. You will also be receiving the presentation slides along with the full recording. Those of you who will attend the entire session will also receive a cool certificate of attendance, so you should definitely stay till the end. And of course, at the end, we will announce our exciting OpenSDK Continuous Flow Challenge winner. So that's going to be exciting, and we've got some surprises there as well. Please feel free to ask questions, but please do so only in the dedicated Q&A section. So leave the chat for chat, and the Q&A section is dedicated for all your questions. We will make sure to address as many questions during this webinar, and of course we will do some live Q&A at the end. So without further ado, I'm really happy to introduce our wonderful speaker for today, Bas Dijkstra. Bas is a test automation expert. He's a main contributor of the TestProject Python OpenSDK. He teaches companies around the world how to improve their testing efforts through test automation. He is an independent trainer, consultant, and developer living in the Netherlands. So I also see we have some people from the Netherlands, so that's cool. And as always, we are very happy to have you, Bas, with us. So the stage is yours.
Thank you so much, Karen. I'm so glad you remembered how to pronounce my last name. But we had a lot of fun practicing last time.
I memorized it.
Yes, you did great. So yeah, on behalf of me as well, thank you all so much for joining this session. I'm really looking forward to spending this roughly an hour and a half. I don't know exactly how it's going to be time-wise, to be honest, with you and showing you all the exciting things that Karen just talked about. So let's get started. As I said, my name is Bas. I'm from the Netherlands, and I'm pretty much, yeah, well, I do whatever Karen just told you, so no need to spend any more time on that. Let's get rolling. So, as promised, before we go into the main subject of this webinar, which is how to integrate your Python OpenSDK, TestProject OpenSDK Python-based tests into a continuous integration and continuous delivery flow, we'd like to show you what has happened since the previous webinar and since the introduction of the Python OpenSDK a couple of months ago. I've been positively surprised and humbled by all the feedback that we got from the entire community from all around the globe about how useful this was and how easy it was to set up, because that was exactly what we had in mind when we built this SDK. And in true open source fashion, I also loved how people made suggestions for contributions, had questions, had reported issues. Of course, it's never fun if people report issues, but they were actually some incredible opportunities to improve the and not only the Python SDK, but the entire range of TestProject SDKs, because as you know, besides the Python SDK, we also have Java and C# SDKs. And some of the suggestions that people made on how to improve the Python SDK were also applied to the Java SDK and the C# SDK. So it is really valuable and useful for all of us to please keep of course keep sharing how much you like working with this SDK. But if you think there are things that could be improved or that could be done differently, please feel free to either submit a pull request or just file an issue on GitHub and let us know what you think could be improved or could be done differently. So I'm going to show you two changes that have been introduced in the most recent version of the SDK, which is 0.63.15. And both were made on request from the community. So and this is, to be honest, this is one of my first that I'm doing a project like this as a core contributor to a project, and I'm loving it. I'm loving how people from the community suggest improvements and stuff like that. And both these improvements that I'm going to show you are they come from the community. It's not like we thought them up or other people at TestProject. No, these come from the community. So the community really improves the SDK as well. I'm going to show you two of those improvements. The first one is the fact that we now automatically create a screenshot whenever a WebDriver command fails. Before, obviously, you had the option, the ability to include screenshots in the projects that are sent to the TestProject platform. But as some people commented, this got a little tedious because you had to do that using a manual step, using driver.report.step, and then set the screenshot flag to true. And people say, I want a screenshot every time a command fails, some action on an element in one of my test fails. I want a screenshot. I want to see what the page looks like at the moment that command failed. So that's what we built in. And the other improvement is the ability to automatically report assertion errors. So these are not specifically, as you know, the assertions are not part of Selenium or of Appium. So this was this took a little bit more thinking, but we got several people requesting, well, if I have assertions in my test and they fail, I want to see that reflected in my test project report, the report that's going to the test project platform. And before, if the entire test went well, everything went okay, all WebDriver commands were executed successfully, but one of the assertions failed, your unit testing framework, so PyTest or unit test, indicated a test failure, but this was not reflected in the test project report. So the report on test project showed that the test passed, whereas your unit testing framework, run on a machine where you run your test, showed a test failure. So we came up with a solution for that as well. So let me quickly demonstrate those two features before we go into the main topic of this webinar. So I have a straightforward test here, which runs on the test project example website. It performs a login action and it checks if a greeting is displayed. This test passes. which is is not weird because that's not what these new features are about. But if I, for example, change one of the, let's change the locator, the CSS selector for the login button, and now say instead of login, let's call it logout. That's a button that does not exist, which means that there's a WebDriver command that will fail because it cannot find the element that we specified. If I run this test, of course, all using the Python SDK run through our agent that's running here in the background. It's starting my test. It's going to log in. So as we see, it generates it's not actually so there's probably a logout button hidden somewhere, but it's not interactable, which is also fine because that means a WebDriver command failed. And if we then go away, our reports on the TestProject platform and look at and we can see that the click of the logout failed because the element was not interactable, and it now automatically included a screenshot of the current state of the web page at the exact moment that the WebDriver command failed. So you don't need to configure anything in order to enable this. This is default behavior. Whenever a WebDriver command, such as find element or click or send keys, fails in your test, it will not only report this to TestProject, which it already did, but it will now also automatically include a screenshot, which I think is a very useful addition to the SDK. So this is new from version 0.63.15. The other feature that I wanted to demonstrate is this assertion here. So this is a result. This result indicates whether a specific element on the web page is displayed. So that's true because if the login is successful, this one is actually displayed. Let's invert this assertion to false to trigger an assertion error. So all WebDriver commands are executed successfully, but one of the assertion fails, which makes the test fail, obviously. But I also want to see this reflected in my report on TestProject. So let's run this test again. It takes a while to actually run. And now it behaves in a fashion I was not expecting. So, okay, demo effect, obviously. Luckily, I have a report from this morning, which shows exactly, so what I was expecting to happen. So I'll have to figure this out, but I'm going to do that after the webinar, why this did not run as expected. Let me see where it, yeah, here it is. So I get it. I get why this was not working. Let me quickly restart my PyCharm. I need to enable it. What I forgot to enable. I don't just have to invert the assertion. I also need to enable this reporting of assertion errors by adding the report assertion errors decorator. So let's quickly try again, just once more. But it actually works as expected. So if I want that those assertion errors to be reported in a test, I need to add the report assertion error decorator to my tests, and this enables. This is much better. This enables the SDK to also detect whether an assertion error occurred and report that to the test project platform. So let's refresh this is much better. This is exactly what I was looking for. So now you see that the test failed with an assertion error and a message, well, I tried to perform an assertion. I expected a value false, but the actual value was true. So, and you can even see in which line of your test method this assertion failed, which allows for easier debugging and fixing of your test. So, recapitalizing, this is a new feature which allows you to report assertion errors. But in order to enable it, you need to have the latest version of the Python SDK, as well as add this decorator to all of your tests. And it's probably also good to know this works for both PyTest, which I'm using here, as well as unit test. So we've tested this for unit test as well, and this works fine for unit test too. So that's what I wanted to show you about new features in the Python SDK. One final thing that I also wanted to mention is you've probably all seen that Python 3.9 was released a couple of days ago, maybe a week ago, something like that, or released to the public at least. We've already done some test drives on the SDK with the latest Python version, and this seems to work without any trouble at all. We've done some tests, and it seems like that the SDK is fully compatible with the latest version of Python as well. So using our SDK should not be holding you back from upgrading to the latest Python version. So that's probably a bit of useful information for those of you considering to upgrade your Python version as well. Let's talk about continuous integration and continuous delivery, because that's what you all signed up for, right? Before we dive into actual features and how to build a pipeline that includes tests based on the TestProject Python SDK, let's address why you should do this in the first place. Why should I do continuous integration? Why should I do continuous delivery? What are the benefits that it brings? Why should I be doing this? Simply because building and deploying an application often takes up a lot of time, and the process consists of many different actions of different kind of platforms using different kinds of tools. But it's the more often you want to release new versions of your project, the more often you have to go through that entire process. So, and as IT people, we're all lazy, so we try to automate that away. Building a continuous integration or continuous delivery pipeline is a perfect way of automating this process of building and releasing new versions of your software. A big benefit of S2 is that running automated tests, no matter if they're unit tests or integration tests or end-to-end tests or performance tests or security tests or any other kind of tests, they can be made an integral part of this process. And that's what we're also going to be talking about, and what I'm going to be demonstrating today. Why? Because I want this also enables me to get fast feedback on the changes that I've made. If I create a pipeline or a process that runs a number of tests, and again, this can be all different kinds of tests, that's dependent, depending on your context and on your needs. Any type of test, whenever a new version of software is being committed to a version control system, for example, the developers and the entire team in the end gets very fast, quick feedback on the overall quality of the project after the change has been made. Feedback on, didn't they accidentally break something? Did it work according to the specifications that they codified in their tests? If you wait until much later in the process, developers will have moved on to other stuff, and all this context switching takes up a lot of time and energy, and it just slows down that whole feedback loop. And you can't deliver software faster unless you have a quick feedback loop which gives you information about the quality of your product in place. And as a side effect, it ensures that your tests will actually run frequently. If you have an automatic trigger that will run your tests at certain points in time, either whenever a new commit is being made into version control, or every night, or every weekend, or no matter what the frequency is with which your tests are run, if you automate that process of running your tests will actually get run, because test automation is useless if you don't run your tests. It's only when you run your tests that your test automation becomes useful. The actual creation of test automation, I'm sorry, but that's not all that valuable. It's in the running of your tests. That's where the actual value is, and in the information that's being returned by your automated tests. So integrating this into a CI process will ensure that your tests get run frequently and that they will actually be valuable to your team. Let me quickly sketch what a CI/CD pipeline might look like for those of you who are maybe less familiar with this. We need an orchestrator. We need an engine, an orchestrator. People sometimes compare this to a conductor in an orchestra, and we need a tool that orchestrates the entire process, that performs the different tasks, sees whether or not those tasks pass, move on to the next task, and control all of the other different kinds of tools that perform the individual tasks in the entire process. This can be done by popular solutions to do this are Jenkins, GitLab, CircleCI, Travis, Bamboo. There are dozens of these different CI systems. What you also need to do, because typically this is what you do with multiple people, with your entire team, is a version control system, a central repository to store both your application code as well as your test code. And we're going to talk about version control in a little more detail in a couple of minutes. But without version control, you can't really work together as a team on a single piece of software. That's incredibly hard, at least. The orchestrator, so Jenkins or GitLab or whichever tool you're using, is going to pull code from your version control, application code, and test code, perform some tasks on it, build the application, run the tests, deploy the application somewhere, and it's going to generate reports, and those reports can be either consumable for other human beings, or for other machines. So these can be reports in all different kinds of formats. And ultimately, and this depends a little on how far you are along in the evolution of towards through continuous deployment, is it's going to make decisions at this orchestrator about whether or not it moves on to the next stage of the continuous integration and continuous delivery process. And ultimately, this can be, well, just put a new version of our software into production and make it available for all of our users. So, but it's going to make decisions based on the results of the execution of the tasks, and most importantly, and that's what we're going to talk about today, based on the results of executing your tests. So, and some of these tests might be our test project based Selenium and Appium tests, and that's what we are going to that's what I'm going to demonstrate today, how to create a pipeline that pulls your tests from version control, runs them against an application, does some reporting, and automates this entire process. Before we can actually start running our tests and building our pipeline, we need to install an agent. So you need to do that whenever you develop the TestProject SDK based tests on your local machine, but you also need to install it somewhere where it's accessible for your continuous integration orchestrator. And so you need to install, and you can do that in two different formats, really. So either you can do a local installation, which means you download it from the download an agent from the TestProject website, and then install it on, for example, a Jenkins node that's running the jobs. That's also what I'm going to be doing today. I use a local installation, be it the same agent that you just saw performing the test showing the new features. So I'm using an agent that's running locally. The other option is to use a Docker image. The people at TestProject also enable you to use a Docker container that contains the TestProject agent. So and you can use that to automatically build up your entire test environment, including that agent that has to be run somewhere, all using Docker. So for this demo today, I'm not going to use Docker. I'm going to use an agent that's running locally. If you want more information about how to run your agent from within Docker, I can recommend you read. There's a great article on the TestProject documentation website that explains how to do this and where to get the Docker container from, stuff like that. And another very good resource for this is watching the YouTube videos by, and I don't know if you're listening, but I hope I don't butcher your name, by Raghav Paul. He created, and he just released them this week or maybe last week, a couple of great videos which explain step by step how to configure, install, and use the TestProject agent running inside the Docker container. So if you want to use that, or if you want some more information about that, I can highly recommend either reading this article, or looking up Raghav on YouTube and watching his videos on how to do this. And just to show and give you a little bit more proof that it actually works, This is a screenshot from the Python SDK repository itself. And we publish the Python SDK using a continuous integration system. And we run tests against our own SDK in a continuous integration setting. So we all, and we do all other kinds of checks as well. And as you can see here, this also uses, and because we do some static analysis, some linting, we run unit tests against our SDK code, but we also use our SDK to run some functional tests. And because we also want to know, does the latest version of our SDK work as we expected? We also need an agent for that. And inside our own build process for our own SDK, we also use this Docker agent, just like you can do in your own continuous integration flow. So this is just to show you that this, I'm really not making this up. And this is something that we use ourselves as well to build and test our own product, our own Python SDK. So let's go through the entire process of building and running this pipeline one step at a time. Because we're programmers, we're starting to count by zero. First, the first thing we need to do is setting some environment variables. Why do we need to do this? We need to prepare our environment so that Jenkins or GitLab or CircleCI, in this example, I'm using Jenkins, but we need to make known some settings. And in this case, there are two settings that are especially important here. We need a developer token, which without a developer token, I can't communicate with the agent and the test project platform from within my tests. And second of all, I need to tell the SDK and my tests essentially where the agent is running. So I need to specify where the agent is running. So that this can be inside a Docker container, it can be anywhere really, as long as you've got, it's not necessary that your agent runs on your own machine. You can have it running on an entirely different machine if you want to, or inside an entirely different Docker container, for example. As long as you know its address, you can configure it in the TP agent URL address, and you should be good to go. So let's take a quick look at my pipeline here, at the configuration of my pipeline more. So I created this in, let me zoom in a little so that it's easier to read for everybody. I created this pipeline as a script because that gives me a lot of flexibility really. And so the first step here is to set some the environment variables that I want to use here. The agent URL, that's not a secret at all, so I can just specify that in here. And so it runs on my local host on port 8585, which is the default port, by the way. So that's fine too. And the value for my developer token, I stored that inside a credential area in Jenkins. And every major continuous integration engine has something as a way to securely store secrets, passwords, these kinds of tokens, other types of sensitive information in a way that so that it's it doesn't show up in your pipeline script itself. Instead, it's stored securely somewhere and retrieved from that store whenever the pipeline is being run. So I've done the same here too. I created a credential with this specific handle, this specific name in Jenkins, and this refers to my actual developer token. And so that's the first step, setting these environment variables. So my Jenkins job knows what my developer token is and where it can find my agent. So that's step 0, really. Step 1 is making sure both my application and my test code is under version control. And in this example, it's just test code, really, because my application is already running somewhere on the internet. But my test code is in Git. Is stored in Git, is accessible via GitHub. Why do I want to do this? First of all, I want to ensure that I have access to the latest version of the code, and I have and that it allows me to, and much more importantly, it allows me to collaborate on a single code base with more than one person. If you don't have a version control mechanism in place, it's going to be really, and if more than one developer is working on the same code base, it's going to be really difficult to keep track of who is making which changes in which files. And it's going to be an incredibly difficult task to make sure that all of the changes are merged and that you can roll back to previous versions if something went wrong, that you keep it all clean and organized. And that's exactly what a version control system can do for you. So just to show, I've got this was my new feature. So this is my sample test. This is the test that I'm going to run as part of my pipeline. It's pretty much the same test that we just saw with a couple of small changes. And I've stored this, just so you know, that's actually on the version control. I've stored this here in GitHub. So if I go to tests, you can actually see this sample test file that contains my single test that's going to be run by Jenkins. So then the next step, the next stage, or at the first proper stage in my pipeline, the first step is to check out these tests from Git, and that's what I'm doing. And this is different for each individual continuous integration product or system, and this is just how to do it in Jenkins. GitLab does it differently, CircusRite does it differently, but they all do the same thing, really. So how exactly this works in Jenkins isn't all that important to get. The important thing is this is the step where the code is being pulled from version control. So what I'm talking is I'm using the Git source control management system. I'm pulling this from the master branch, which is important because you can also pull code from different types of branches if you want to. And of course, you need to specify the address. So the address of the repository where that code resides, where that code is stored. And as you can see, this is the exact same URL, the exact same endpoint as we saw here. So and this stage in my Jenkins pipeline ensures that before anything else is being done, the latest version of my test code is being pulled from Git, from my version control system. The next step is installing the dependencies that I need. So to be able to run my code and run my test code, I need to use some dependencies. First of all, the SDK itself. The SDK itself is a dependency to my test code. It's not actually part of my test code, but Jenkins needs it, or any other CI systems. They need it to be able to run the tests, because the test code relies on the SDK, because it uses the SDK. And so this test code, and the same goes for application code, it requires third-party dependencies to run. Now you could technically download all of those dependencies and store them in your version control together with the code that you're working on. Please don't do that. That's what package managers and dependency managers are for. And because that code isn't actually part of the project that you're working on. Sure, your code needs those dependencies in order to be able to run it, but it's not actually part of it. So and if you store a specific version of that dependency inside your version, it's going to be a mess really quickly, especially if you get upgrades and you want to upgrade your dependencies as well. So please don't do that. So please don't store those dependencies in your version control as well. Just make sure that they're available when you are going to deploy your application, or when you're going to run your tests, which is what we're going to do here. So before now that we've checked out our test code, we need to install some additional dependencies before we are able to run our tests. As I said, the typical way to do this is by using a package or a dependency manager. And these are different for each language. Because we're talking about Python here, we're going to use pip, which is the default Python package manager. At Java has Maven or Gradle. C# has NuGet. JavaScript and Node has NPM, for example. So each language, each ecosystem has its own dependency manager. I'm going to use pip here because we're using Python. So as part of my project, I created a txt file which lists the dependencies that are needed for this to run this code. And in this case, as I already told you, there are two different dependencies. The SDK itself, so the TestProject Python SDK itself, and PyTest, because I'm using PyTest as my unit testing framework. So the next thing I need to do is to, as part of my pipeline, is to make sure that those dependencies are installed and available. And the way I do this with pip is by running a command line instruction, either pip install then the name of the package, or if I create a requirements file, just like we saw, running pip install -r and then the name of your requirements file, which is typically requirements.txt. And what pip, the Python package manager, will then do is it will install all of the dependencies that are listed in that file. And in this case, there are just two. And it also allows you to specify specific versions of the packages. So in this case, I chose the latest version of the SDK, as well as the latest version of PyTest, at least at the moment of this webinar. And so it'll install those to make sure that those dependencies are available once we start running our tests. And this is the next stage in our pipeline to install the dependencies just before we run the test. And in this case, it's as simple as running a script with a batch file saying pip install -r requirements.txt. So this txt file, that is in the that is part of what's being stored in version control, obviously, because that is part of your code, a list of the dependencies. Just like you have a pom.xml in if you're doing a Maven-based Java project, that contains a list of dependencies. So, and with Python, you use a requirements.txt, which lists those dependencies. So at this second stage, this installs the necessary software, the necessary libraries that I need to run my tests. The third step is finally actually running our tests. Typically, this is done by invoking a unit testing framework. Why? Because a unit testing framework will do the test collection and the test execution for you. So a unit testing framework is able to scan your code base and see where the tests are and which of the methods in your code are test methods. I'm using PyTest in this example. The Python SDK supports both PyTest and unit test, as you probably know. The Java SDK, for example, supports both JUnit and TestNG, so both JUnit 4 and 5 and TestNG, so you can use that as well. But typically the way you run tests from the command line is either by invoking the unit testing framework and telling them where which part of the code base to look for, to use to look for tests. Or have for the if in case you're using Java, you can also use Maven to run your tests. But that's because Maven is not only a package manager but also a build tool. Pip is just a package manager, so we can't use that to actually run our tests. But we can invoke PyTest from the command line or unit test from the command line and run our tests inside our command line, inside our Jenkins job, inside our Jenkins pipeline, like that. One other thing that's incredibly important is to make sure that your continuous integration orchestrator, in our case Jenkins, is able to parse the test results, is able to understand what is the result of the execution of your tests. And the way that this is typically done is by making sure that your unit testing framework, which takes care of collection of your tests and the execution of your tests, and to make sure that your unit testing framework generates an overview of which tests were run and what the corresponding results were. This is typically done in the form of an XML file, which is known as the JUnit XML format, which is a little confusing because it's not just JUnit, the Java unit testing framework, that can generate this format. PyTest can do it. PyTest and unit test can do it as well. PyTest doesn't do it by default, so we need to explicitly specify that we want a we want our test result, so the result of our test execution, to be recorded in this XML format, so that Jenkins can pick it up, so that Jenkins can understand what happened. So what does this look like in our pipeline? So this is the stage where we run our tests, and in this it's as simple as executing a command line instruction saying PyTest and then the name of the specific module, because it's just a single test that I want to run here. It is in sample test.py, and explaining and asking PyTest to generate a JUnit XML results file in the results folder with the file name result.xml. So this is completely up to you where exactly you store this. I chose to create a new folder, results, with a result.xml. Before I'm going to quickly show you, what that looks like. So paste, there we go. So this is going to run a test just to give you a quick look at what this XML file actually looks like. So this is a standardized format. So it failed. That's all good. And this is the XML that was created. And this is standardized format. So where is it exactly? So it just here in the top line, you can see, well, it used PyTest. There were no errors. There was one failure. There were no skipped files. And there was one test run. It took me 12.3 seconds. There's a timestamp there, the host name, and information about the specific test case that was run, its class name, and the name of the test itself, test sample, and the failure message with some more detailed information about why exactly the test failed. So this is generated by PyTest, and because this is in a format that Jenkins understands, Jenkins is then able to pick up that XML file and make decisions based on it. So parse that XML file and see, well, did all the tests pass? If so, we can move on to the next stage. And if not, it's going to, unless you tell it otherwise, it's going to stop this build. It's going to mark this build as failed and not deploy something into production, for example, because some of your tests did not pass. At the final stage, and I already sort of kind of explained this, is the test results that were generated by the unit testing framework need to be published. So they need to be visible. They need to be picked up from where PyTest put them, and decisions need to be based on those test results. And Jenkins and many other CI systems also have a way to create nice graphical representations of test result and test result trends, for example. So pick up those test results, publish them for the world to see, and Jenkins creates some graphs and overviews automatically. And this final stage is, I've marked this as a post stage, which means it is no matter what happened in the previous stages, this stage is always executed. It's going to pick up all XML files in the results folder, because it might be true that something failed earlier in the pipeline and no tests were run. You can enable that in Jenkins like this. And again, different CI orchestrators do this differently, but they all allow you to do this. It's just the way in which you do it is to specify this is a little different from one CI system to the next. So in GitLab, it's a little differently than in Jenkins. In Circle CI, it's differently from GitLab and Jenkins and so on. But they all allow you to do something like this. So, and this is our entire pipeline. Four stages and one preparation stage. So setting the environment, the right environment variables that we need, checking out our test code from Git, installing our dependencies, so the SDK itself and PyTest, because that's what we need to run our tests, actually run the tests, and then pick up and publish the test results. So if we save that, and I'll go back to irrespectable and say build now, and that's the way in Jenkins at least to manually trigger a new job. And you also see that it's going to run a new job in this case. So this is a menu. I've now triggered it manually, but you can also configure Jenkins or any other continuous integration platform to automatically run run a job either at certain times of the day, so once every hour, once every night, once every weekend, all depending on whenever you want to run your tests. But you can also say, well, do this whenever a new commit is being added to a specific branch of your version control, for example. So in the meantime, our pipeline completed and it failed. It showed a failure. So if we look at the details for this specific build, it's unlucky number 13, so it was probably bound to fail. It shows a test. It shows here our test results. So this is all parsed by Jenkins from that XML file that I just showed you. This is all information that was part of this XML file. And you can see here, well, this is the error message. There's a stack trace there. And this is what happened. And if we go back to that, you can also see a test result trend here. So there's good news and there's bad news. Our pipeline worked, so that did its job just fine. It's just that there's a test failed, and that made that the result of the of our text execution to fail, and this nice red dot to show up. So this is typically this is shown on a big monitor, then on your wall, or Jenkins sends some emails to people saying, "Hey, this build failed," with maybe some more information about why exactly it failed. And in this case, it's because our sample test failed. Now I put in this. No, let's first review the results on TestProject. So it ends up in this same project. Here we go. Come on. Yeah. So this is our test run that we just completed. Our test failed because of the assertion error, because that's what that's the part of the test that failed. Our assertion failed. So it shows this nicely. So our reports in TestProject reflect the result of our build pipeline in Jenkins, which I think is a good thing. So let's fix that. Now I made this test fail on purpose because the password that I entered is incorrect. It should actually be 12345 instead of 12346. just changing this on my local machine obviously is not enough. I need to make sure that this goes into version control. So let's add this. This is I use the command line interface for Git a lot. You can also do this from within PyCharm or any other IDE or another Git client if you want to. That's really based on personal preference. So I fixed my test. So I need to update the version in Git in version control with my latest changes. So I hopefully fixed the tests now, and git push, and push them to Git. So if we go back to our Git repository now, we can see that there's a new commit just seconds ago with the commit message that I specified. So our updated tests are now in version control. And because they're now in version control, if we run our pipeline again, our CI/CD pipeline again, and we told our pipeline to always check out the latest version of our code as part of the build pipeline, this will hopefully, fingers crossed, now also result in a green pipeline because we fixed our tests. Yay. So because I fixed our test, I changed the test code to use the correct password instead of the incorrect one, and committed that to version control and rerun the pipeline. It'll now show, it'll now run successfully. There are no more reasons for Jenkins to mark this build as failed. And if we go to the build information, we can also see there are no failures anymore. All the tests with just one test, but work with me here, it passed. And if I look at the console output, you can also see what exactly happened when we run this build. And the most important part is, here it invokes PyTest, and there's one test, 100% of the tests passed, and the entire pipeline finished successfully, which you also saw. And the trend now show that the latest build number 14, had no test failures. So all is green, and our application is now ready to move on to the next stage in our deployment pipeline. So that's a complete continuous integration flow, committing code to version control, building a pipeline, pulling that code from version control, running our test project tests using PyTest from the command line, and displaying the results in Jenkins. And of course, as well, in test project itself. Now this annoying bar is preventing me from going to test project, so let's do it just a bit here. And my latest, there it is again. The latest test result now also shows a nicely a passing test here. So we fixed our tests, and we are good to go here. So that's the entire flow, really, the entire continuous integration flow. Version control using an orchestrator like Jenkins or GitLab to run our test project-based tests, communicating with the agent, setting up the environment so it can use the agent, picking up the test results and displaying them in Jenkins as well, so that Jenkins can decide what to do next. And I'm not going, I'm not actually deploying an application here, but this is so this is the end of our little pipeline here. But typically, this is a trigger for Jenkins to maybe deploy an application somewhere in production. Before we move to the Q&A section, I think we're nicely on time here. That's good. I would just want to spend just a couple of minutes or just a little bit of your attention to making your tests fit for CI/CD. To be able to do this, your tests need to fulfill some conditions. If you want to properly integrate your tests into a continuous integration pipeline as part of this Jenkins job or a GitLab job or anything, your tests need to fulfill some criteria, really. First of all, they need to be trustworthy, because Jenkins is going to make decisions, for example, the decision about whether or not to deploy an application into production based on your test results. That means that you need to be able to trust your tests and to make sure that they pass when they need to pass and that they fail when they need to fail. So you should eliminate these false positives and false negatives, and that's hard often. But you really need to really make sure that these tests can be trusted, because if you do through continuous deployment, those automated tests are the only gatekeeper between a developer's machine and your production environment. So you need to definitely be able to trust your tests. If you see flaky tests, or tests that sometimes pass, sometimes fail, address them as soon as possible, because they're going to generate noise, and they're going to be frustrating to people. So, oh, our build failed again. Yes, that's because of this and this flaky test. We can just ignore this. No, you shouldn't ignore it. You should address it. So either remove the test altogether, because to be honest, I'd rather have no test than a flaky test, or fix the test so that it always gives a trustworthy result. You should be very careful when to run which tests, because a unit test, you should run them all the time, really, because they are fast, they are cheap, but especially the kind of test that you've just seen, they are slower. So you might not want to run them on every single commit. You might just want to run them once a night, for example. If you have long-running performance tests, you might just want to run them once a week and not on every commit, because that's just too expensive and that's not contributing to faster feedback. And finally, you make sure your tests and basically your entire pipeline are completely autonomous. So your pipeline should be able to create its own environment and set the required state for your tests, and for the building and deploying of your application as much as possible. And yes, that's hard work. And yes, you need to, especially things like test data can be pretty challenging in this process. But unless you make sure that your tests are absolutely autonomous, so they don't rely on one another and they don't rely on things that you assume to be there. So you assume that some data is there, or you assume that an application is deployed somewhere. No, you need to make absolutely sure. And yes, that's more work sometimes, but it'll have a highly beneficial effect on the success of your CI/CD implementation, really. So yes, by all means, do make your tests part of this pipeline. I've shown you how to do this for your TestProject SDK based tests in Python. But before you do that, make sure that that it ticks all of the boxes on this slide, because if not, it's going to be it's going to cause a lot of noise and a lot of trouble, really. Okay, Karen, do we have any questions? It's 3:45, so we have 15 minutes. I see a red 12 in the Q&A, so there's probably at least a couple of questions.
Yeah. So first of all, thank you very much, Bas, for this wonderful presentation. You can see already in the chat as well, people are loving it. One also called it a wonder demo, so hats off to you. So we appreciate that.
Well, I did not keep track of the chat, but thanks.
Yeah, people really enjoyed. So now, yeah, we have a couple of questions here. We the team tried to address some of them. There were a lot of questions coming up. So let's see out of those open, which ones we can help address.
Yes. Do you want me to pick some?
Yeah, sure. Go ahead.
I'll just start from the top, really. Vegeta asks, is there a doc containing dependencies info? I'm not sure which dependencies you mean. For this demo and my test relied on two dependencies. First of all, the TestProject SDK. And second of all, PyTest, because that's the unit testing framework that I use. But it really depends on the, and maybe your test code, your application code too, has entirely different dependencies. So, and these are also PyTest and TestProject Python SDK. These are all standard dependencies, and in order to, and something I did not mention, but I'm going to do it now, is these are pulled from PyPy, which is the Python package index, and this is where pip downloads the dependencies from. So every time we release a new version of the Python SDK, we publish a new version to PyPy. So if we do pip install testproject-python-sdk, it pulls the latest version from pypy.org. And the same for PyTest, for example. So PyTest is on here as well. And they're typically, if you need documentation about specific dependencies, they're listed here on PyPy as well. So for PyTest, there's a project homepage and stuff like that. And for our TestProject SDK, we have a homepage, and we have some documentation about the dependency here as well. And this is the same as on GitHub. So I hope that addresses your question at least a little. If not, hit me up later, and I'm happy to address this at some later point. Fiber, and if we talk about the remote machine, that agent is set up there, so agent will always, we can down it also. Again, it depends really. So if your agent is running on an entirely different machine, if you build your pipeline, you still need to make sure that the agent is running there. If it is a persistent installation, just like I have on my own machine, and it's just running there all the time, then you might just want to do a quick check to see if it's live. So the agent itself also has an API which you can use just to see if it is running, for example, and do that check as part of your pipeline before you actually start running your test, because it doesn't really make sense to run your test if the agent is not up. If you're using Docker, starting the Docker container that contains your agent, that is running your agent, is just another step in that pipeline. So that's why Docker is so useful. It'll because you can just spin up your entire environment and all of the dependencies and all of the systems, including the test project agent, as part of your build pipeline. Asim, can we run a CI/CD pipeline without a developer token? Yes, but you can't use the test project agent and the test project platform, because you really need a developer token for that. Developer tokens are absolutely free, because test project is free, and please correct me if I'm wrong, but I think you said it's intended to be free forever, Karen. So a developer token is absolutely free. So, but you need a developer token to use the agent and use the platform, because it is the developer token that makes sure that the test results are uploaded to the right location, and only you and your team can see the test results, and not everybody in the entire world can see them. That's all managed using the developer token, because that's associated with your account on TestProject. Developer token will be the same if we have multiple projects. That depends on your requirements. So you can use the same developer token for multiple projects, because if we go to test project here, I can have a lot of different projects here, and they all use the same developer token. But you can also say, I would have completely different portals on test project for different projects or for different types of tests, and that's all things that you can configure on the test project platform as well. So again, it depends. It really depends on your requirements. There's a lot of flexibility and a lot of wiggle room and a lot of customization that you can do there. So I'm going to pick the ones that I think are most closely related to the topic, because I also see some questions that are not strictly related or a little bit off topic for what we're talking about in this webinar. I'd be happy to address those questions as well. I'm just not going to do it as part of this webinar. So if you have some questions that are related to something else about test project or test automation in general, I have one final slide with some contact details, and I'd be happy to address them there, but I want to use the remaining time here to address those questions that are related to the subject that we're talking about, if you don't mind.
Yeah. By the way,
yes.
I just sent over everyone in the chat, so if you have more questions, you can definitely post them on our forum. There's a dedicated thread for this webinar, but even if it's off topic, feel free to post on our forum. Our entire team is pretty much 24/7 there answering questions.
Yes, so. Yes, you shouldn't, but you are. Yes.
Yeah, we are.
Yeah. So how different is it to do the configuration for the project to run in Travis, Raul? I don't know, to be honest. And why? Because I've never used Travis myself. I've done it in Jenkins and in GitLab. I have some experience with Bamboo and Circle, but not with Travis. I would be surprised if you can't do the same with Travis as I've shown you here with Jenkins. it's just that I don't know I don't exactly know how, because I've never used it. I've never used it before, so I'm afraid I can't really answer that.
Yeah, well, I mean, I assume it won't be that much different, and of course, Raul.
No. It's and most of the features and the options you have are roughly the same with those different engines. It's just the way how you configure it is different. And
of course. Well, Raul, you can always contact the team, and we'll be happy to help you. Maybe Bas, if you could just show the orange button while we're here, the orange chat button in the app, so everyone can also be aware that in addition to the forum,
there is a yes. This one.
Yeah, exactly.
So the chat on testproject.io. Hi, so it's even personalized now. Cool. So you can start a conversation, and I know from experience that the people from Test Project respond way too fast.
Yeah, we do.
And you can ask your questions here. Send a message. Find something in the articles. Stuff like that.
Yeah.
So yes. Let's see if we have some CI related ones. This is the same using of Git version control applicable for recorded tests of test project. I don't know. I don't think so, because you and Karen help me out here and correct me if I'm wrong, but the recorded tests, they are actually stored. Are they stored on the testproject.io on your platform?
Yeah, so they're on the platform, but I mean, of course, you can. There are a bunch of options there for version control. We're also working on a built-in solution for that, but at the meantime, without using Git version control, you can simply duplicate your projects or your tests, and that way call it in different versions and monitor that for the recorded tests, at least in the meantime. But we're working on some good stuff for you on that area as well. So
okay, I have less experience with that part of your platform. So how about GitLab, Asim? Same as for Travis, probably. It's a little different there, and you configure GitLab pipelines in a YAML file. But the steps are basically the same. You build stages, and in each individual stage in your pipeline, you perform a specific task. So installing pulling things from version control, installing dependencies, running tests, for example, publishing test results, or all that kind of stuff. We actually build our the SDK itself using a GitHub pipeline. So that's very similar to GitLab, and so I have a little more. I'm a little more familiar with that as well. But so it definitely, we can do the exact same thing with GitLab too, really. So is it possible to do CI/CD for mobile testing using Python Test Project SDK? Absolutely. So the example that I've shown, the demo that I've shown, is a web, runs test against the web application. Then you can do the same for mobile. Absolutely. The only extra thing that you need to do in that case is make sure that you can communicate with the device that you're testing on. And this can be an emulator that you run on your local machine, or you can use a third-party platform like Source Labs or Browser Stack or cross-browser testing or any other platform. But yeah, it's and other than that, the approach is roughly the same as for this for this web. It's still Python code that you run. You're still using PyTest. You're still storing things in Git. So it's much the same. The only thing is you need that device that you're communicating with instead of just the web browser. I have Kenny asks, have you tried this with the declarative pipeline versus the current scripted pipeline? Declarative is a bit more limited, but can be loaded in Git or in version control. I have not, at least not with Jenkins. I've done something like this with GitLab, and in GitLab you have a pipeline as code, which means that your entire pipeline definition is in a file that is part of your code base. Here with Jenkins, my configuration is in Jenkins itself. Here we go. Yeah, so my pipeline configuration is in here. But I have not tried this, to be honest, because I think this was the most visible way. But you also have the option here to pull a pipeline script from SCM, which is source control management. So if I select that one, I say which one is it? It's Git, and you can pull it from, for example, from the same Git repository and use a Jenkins file there. I haven't actually done this with Jenkins. I've done something similar with GitLab, and that works fine too. Absolutely. So how are we doing time-wise? Oh, we still have one more thing to cover, Karen.
Right, exactly. So
I think now is the time to do that.
Yeah, I think so. So first of all, thank you for addressing all of these questions, and anyone who we didn't get to their question, again, feel free to post it either on the forum or reach out to us directly. And we will also be summarizing all of these great questions you've asked into a blog post in our blog.testproject.io. So definitely follow us over there. And now, for the moment you've been waiting for, we have some winners. We posted up a challenge before starting, before the webinar a couple of weeks back. So we'd like to announce some winners. So there were
should I do the drum roll?
Yeah, definitely. Oh, that's good. So our big winner is Bagiaraj. I hope I managed to pronounce that well. So we'll be contacting you as well. But since so many of you have participated in this challenge, we kind of wanted to give out a special thank you to some additional great posts out there. So we have 4 more people who will be winning kind of another gift from us, which is some test project stickers we'll be sending out your way. So we really appreciate Rishab, Yosli, Vaibhav, and Aman's great posts, and appreciate you guys continuously sharing your awesome support in test project and sharing all the love and the feedback. It really means a lot to us. So congratulations to everyone.
Absolutely. On my behalf, congratulations as well.
Yeah. And again, Bas, thank you too for this wonderful presentation. It's been a blast, and I hope I know people have been really enjoying from the chat, so I can see that as well. And of course, as I mentioned at the beginning, you will all be receiving a full recording of the webinar in an hour or so, something like that, in the presentation slides. And all the winners will be contacted separately as well. Yeah, so we left a couple of social media links here, and Bas, I know you have one last slide of your links, right?
Yes, absolutely. That as I already so if there's anything, first of all, if you have questions about anything test project related, the resources that Karen mentioned are the best way to go. So the test project forum, or post something in the chat, or send an email to, I think it's support@testproject.io.
Yeah, exactly.
Yeah. So, but yeah, if you want to get in touch with me, I have email, and I'm pretty active on LinkedIn as well. So feel free to if you have some feedback or some other questions, I'd love to hear from you.
Great. So thank you, Bas, and thank you everyone for joining. And stay safe out there wherever you are, and we'll be seeing you at our next event. So thank you, everyone.
Yeah, and thank you for having me, and thank you everybody for attending and for taking some time out of your day to watch this webinar. It's been a pleasure.
Yeah, thank you. Bye.
Bye-bye.